Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be discussing Lesson 5 in Unit 7 called Big Side, Big Angle. Our goals today are not those objectives. Those are not the right objectives. Instead, we're going to learn how to distinguish the largest side of a triangle, the largest angle, and the relationship between the sides and angles of a triangle. First of all, we define inequality. Recall that an inequality is any time we can say that x is equal to y plus c. And we use this to define the exterior inequality, the exterior angle inequality theorem by saying that angle 1 is equal to angle 2 plus angle 3. This is the angle sum. And in turn, this means that angle 1 is greater than either angle 2 or angle 3. So an exterior angle is greater than either of its remote interior angles. We're going to use this to great effect when we write our proofs later in this lesson, I guess. Now, let's suppose for a minute that I have two boards, and those two boards are connected by a hinge. As this hinge opens and shuts, what happens to the distance between the two boards? Well, as it opens, the distance becomes greater. And then as it shuts, the distance becomes lesser. You want to imagine that we've strung a bungee cord between these two ends. And as I open and shut it, that bungee collapses or expands or shrinks. Okay. So as the angle gets big, this side gets big. And as this angle gets small, this side gets small. So the first theorem is called big side, big angle. And it says that given two sides of a triangle, the larger angle is opposite the larger side. So if BC is the biggest angle, AB is the middle angle, and AC is the smallest angle, then angle A is the largest. I'm sorry, those are sides, not angles. Angle A is the largest angle. Angle C is the middle angle. And angle B is the small angle. So how does Bsba work? Let's suppose, for the moment, that we have some angle measures. Let's see. We have side measures here actually. So let's say that this is 20, and this is 11. Okay, so we would say that AC is greater than AD because 20 is bigger than 11. All right, and then the angle opposite AC is angle D. So we would say angle D is greater than the angle opposite AD, which is angle C down here, this one. All right, so that's angle DCA by the big side, big angle theorem. Okay. All right, now big angle, big side. So we have two sides of a triangle, and the larger side is opposite the larger angle. So let's have a look here. This time we have angle A as the big value, angle C as the middle value, and angle B as the small value. The sides in order from largest to smallest will be CB, which is opposite angle B. Opposite angle A. And then AB, which is opposite angle C. And then AC, which is opposite angle B. The big angle, big side theorem works by identifying angle measures. So let's suppose that, this is going to be 70, and this is going to be 60, and this is going to be 50. Okay, so we look inside of our triangle and we say, all right, since angle BAC is greater than angle ACB, because 70 is greater than 60, we can say that BC, which is opposite A, is greater than AB, which is opposite C, by the big angle, big side theorem. Okay, so how do we prove this? Okay, it's actually kind of cool proof, and what we're going to do is we're going to draw an isosceles triangle inside of our main triangle. So we know that BC is greater than AB. So we look here, so this is BC, okay, and here is AB. Since we know that BC is greater than AB, we can actually pick a point D on this side. And the way it works, actually let me erase that. The way it works is we're gonna draw a circle, and that circle goes from B to A, just like this, because we know that BC is bigger. We know BC is bigger, so that means there's going to be a point on BC that's the same length from that point to B as A is from B. And that point is right here. So we're going to call this point D. Now, I'm going to take just a second here, and I'm actually going to get rid of this because that big old circle's in my way. And then I'm going to remark that point. There it is, D. And then I'm going to draw a line segment from A to D. Okay, so what we have set up in our proof so far is that AB is congruent to DB by construction. Our goal is to show that all of this angle up here is greater than angle C. And so what we're going to do is we're going to pick out a couple of angles. The first angle we're going to pick out is this one right here, angle 1. Angle 1 is bigger than angle C. And that's because angle 1 is exterior to angle C. This is the exterior angle inequality theorem. So angle 1 is bigger than angle C. Now, we know that this is an isosceles triangle right here, which means that angle 2 is equal to angle C. No, is equal to angle 1. This is the isosceles triangle theorem. And that, in turn, means that angle C is less, whoops, let me, hang on. By substitution, that means that angle 2 is greater than angle C. But of course, we look at where angle 2 is at. Angle 2 is inside of this angle. So I'm actually going to kind of write a little mini proof over here. And it's that angle CAB is equal to angle CAD plus angle 2. This is the angle addition postulate, which in turn means that angle CAB is greater than angle 2. So since angle CAB is greater than angle 2, these things can feed together by the transitive property, and angle A, that's CAB, is now greater than angle C. This was substitution, just so you know, and this is transitive. So there it is. This proves the big side, big angle theorem for any acute scalene triangle. The proof's a little different if it's not an acute scalene triangle, but here, of course, it works. So let's look at the proof for big angle, big side. This is actually a two-case scenario. The first one is that we know that angle A is greater than angle C. And then we want to show that BC is greater than AB. We can do this by assuming the opposite case. In this case, assuming that BC is greater than AB. And what happens here is that one of two cases exists. So if we're not greater than AB, then we're either going to be equal to AB or we're going to be less than AB. We have to test both cases in order to prove this by contradiction. So, case 1. is BC is equal to AB. So if I assume that this is equal to this, what does that mean? It means that this angle and this angle are congruent by the isosceles triangle theorem. So then we would say immediately we would say angle A is equal to angle C by the isosceles triangle theorem because of our assumption. But we know that it's not. So since angle A is known to be greater than angle C, this is a contradiction. Pardon me, this takes a little while to write out. This is a contradiction. Therefore, BC is not equal to AB. Okay, so we've proven that case 1 is not correct. We must now prove that case 2 is not correct. Okay. So here's case 2. Now, in case 2, we make the assumption that BC is less than AB, so that this is small and that this is large. All right, now, we've already proven the big side, big angle theorem. So if AB, I wrote that backwards, didn't I? Oh, no, I didn't. We're good. Got lost. Okay, so if this is the case, then this means that angle C is greater than angle A by the big side, big angle theorem, which we proved just a few minutes ago. So if angle C is greater than angle A, well, you know what? It's not. Okay, the given is the opposite of that, but angle A is greater than angle C. So this forms a contradiction. Okay. Therefore, BC is not less than AB. All right, the result, so since BC is not equal to AB and BC is not less than AB, BC is greater than AB by the trichotomy of numbers. Ugh. There it is. There's your full proof for the big angle, big side theorem.